In single replacement reactions, you'll have one element reacting with a compound. That one element will switch places with another element from within that compound. Metals, like zinc, will switch places with other metals. But also, metals will switch places with hydrogen. Additionally, nonmetals can switch places with nonmetals as well. So, your first question, zinc is placed in a solution of iron 3 nitrate. So predict the balanced chemical equation that would occur here. All right, so zinc is a metal. It's going to be solid at room temperature. All metals are solid at room temperature except for mercury, Hg, that's liquid. And then it's placed into a solution of iron 3 nitrate. All right, so this is missing the word aqueous solution, but anytime you see solution, it's pretty much going to mean that something is dissolved in water. An aqueous solution is agua, dissolved in water. So iron 3 nitrate is dissolved in water, and we also have some solid zinc. Yeah, we can represent the states of matter of these things with S or AQ or L or G. Liquid is L and G is gas. So metals will switch places with metals. So now instead zinc is going to be hanging out with nitrate ions. And then iron is going to be all by itself after the reaction is complete. So iron is over here by itself, and then zinc nitrate is formed. Yeah, zinc is going to hang out with nitrate ions. Now, this is kind of a memorized thing. Most transition metals, like iron, you'll be told the charge of those using Roman numerals. But zinc, if it has a charge, it's always +2. And actually, from the previous video, silver, if it has a charge, it's always +1. Memorized thing, you're not always going to see that. So, we're going to have zinc +2 hanging out with nitrate, which is NO3 -1. In order to have a balancing of charge, you need to have 2 nitrates per zinc. So, now on the right, we're going to have initially just 1 Fe and 1 zinc and 2 nitrates. And on the left, we're going to have just initially 1 zinc and 1 iron and 3 nitrates. All right, so we have the same number of everything except for nitrate. All right, so on the left we have 3 nitrates, and on the right we have 2 nitrates. Oh, that's tough to balance. Oh yeah, least common multiple. Aim to have 6 of each. So put a 3 in front of zinc nitrate, and then you'll get 3 times 2, or 6 nitrates. But additionally, that will change the number of zincs from 1 to 3. So cross out the old ones and put in the new ones. To have 6 nitrates on the other side, put a 2 in front of iron 3 nitrate. So now there's 2 times 3, there's 6 nitrates, and also 2 iron atoms, or ions. So we now have 2 iron atoms on the left, but only right now, maybe just 1 iron atom on the right. Put a 2 in front, boom, balanced out there. We have 6 nitrates on both sides, but zinc, we have 3 on the right, but initially, maybe there's only 1 here. There's 1 zinc. So put a 3 in front as a coefficient, and now you have 3 zincs. Should be balanced now. And then finally, solid calcium is placed into water. All right, so calcium is solid. We can show that with this parentheses S, parentheses, and water. Now, you might be used to writing this as H2O. That's how most people do it. But I actually find that it's easier to predict the products of reactions with water if you write water as HOH. Then calcium will just switch places with just 1 hydrogen instead of the 2 that you would have with H2O. So calcium switches places with hydrogen, so now you'll get calcium next to the OH and hydrogen now by itself. Now we don't just write H here. Pure hydrogen is a diatomic element. So if you have pure hydrogen, it's actually H2. And then we'll have calcium hanging out with the OH. Now, that's hydroxide on your polyatomic ions list. That has a charge of -1. So crisscross, calcium hydroxide has 1 calcium and 2 hydroxides. It's not 2 H's, it's 2 OH's, parentheses, if there's 2 or more polyatomic ions. So to balance now, we have 1 calcium and initially just 1 HOH. Now I'm going to make this easier to balance by writing H's separate from OH's. So initially we just have 1 H and 1 OH. And then on the right we have H2, so there's 2 H's, but we also have 1 calcium and 2 hydroxides. So we're not balanced for H or OH. Over here we have 1 of them, but over here we have 2 of them. But if you put a 2 in front of water, we'll have 2 H's and 2 OH's, and so we'll be balanced.